Now that we've covered the server structure and functionality in quite a bit of detail, let's start talking about the client structure and functionality. And this will give us a chance to talk about a whole bunch of other interesting and cool new things that we haven't covered yet that will be relevant in upcoming programming assignments. In particular, we're going to talk about something called the Spring HTTP Interface Clients feature and show how that works. In fact, we're going to start with that because that's helpful to understand everything else. So with Spring 6, which was a recent version of Spring, they probably moved on to something new by now, but that was a version that was new about a year or so ago, 2 years ago. They had this new feature called Interface Clients, and you can use it to declaratively define client-side HTTP resources, in particular proxy. And this does a couple of different interesting things, actually a half dozen or so interesting things. You can have these declarative clients. So you can use a Java-like interface style of defining the clients. So you can see here we say public interface, lock API, lock acquire. We have a release method. It's got parameters. It actually looks quite a bit like the controller logic. And the nice thing about this is we don't have to manually create the client code for the proxies. This is the corresponding, this is code that we had for other stuff that you did in the class for an earlier assignment. And we had to do all the things like making a URI components builder, adding the path, adding query parameters, blah, 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 blah. Very complicated, very tedious, and error-prone to program. Another nice feature of the HTTP interface clients mechanism in Spring 6 is it's annotation-driven. So we can use annotations that you're already familiar with or close to being familiar with in order to be able to map client interface methods to HTTP requests of various flavors. So here, for example, we have the post annotation, post exchange, which is very much like post mapping on the server side. In fact, some of the annotations are identical to what you see on the server side, in particular request param and request body. These almost mirror one-to-one the way you would define the controller annotation. So that's nice. You don't have to go out and learn some new annotation mechanism other than post-exchange versus post-mapping. There's also this neat feature, which we'll just touch on briefly here, and then we'll cover it a lot more because it really becomes useful when we start doing asynchronous programming, is integration with something called a WebClient. And WebClient is a more advanced way of interacting with microservices or web services that allows both blocking and non-blocking operations. So you can both do synchronous stuff, which is what we're doing here, as well as asynchronous stuff. And you'll see how that plays out later. And this is how you make a web client. You use a web client builder, give it the URL to the server, and build it. There's other stuff, too, we'll talk about, but that's the basics. As I mentioned, the nice thing about the web client is it supports both synchronous and asynchronous communication. So here, because it's a synchronous example, we're going to make requests and get back lists of things, but you can also use it to get back reactive types like fluxes that can stream things back asynchronous. Something else that's kind of cool with HTTP interface clients in Spring 6 is the ability to do dynamic proxy implementation. So all the stuff, all these proxies are actually implemented at runtime. So I asked ChatGPT to generate me a visualization of this, and it came up with it looks kind of like Groot from the Guardians of the Galaxy, but it basically is like showing a little tree that's growing these proxies live. And this simplifies your implementation because it abstracts away all the HTTP request handling, all the things about connections and sending and receiving requests and responses, converting responses to Java objects. That's all done for you by this generated proxy without you having to write the code yourself. The other nice thing about using this approach is it's very type safe. There's compile time checking for different parameters. As you can see here, all the parameters are type checked correctly. And this minimizes runtime errors due to type mismatches. There's this funny cliche that people used to say 40 years ago, strong typing is for weak minds, which isn't really true. Strong typing is just a good idea across the board. Those people who have the misfortune of suffering with languages that are dynamically typed, like JavaScript, hopefully can appreciate the downside with using dynamically typed abstractions and languages. Another nice thing about the HTTP interface clients feature is it reduces boilerplate. So repetitive code is sucked up into the interface. You don't have to write it. You don't have to repeat yourself. You don't have to waste time making changes that you have to modify. Anybody who had to address some of my comments for assignment 1A and 1B, where you incorrectly implemented one of the different proxy methods, but were not doing it consistently, you had to go back and find where you were doing things inconsistently and change them by hand. There was no easy way to do a global change. Whereas with this stuff, you don't write any of that code at all, so it reduces the amount of boilerplate code you write. And it also helps you focus on the what, not the how, which is really the theme of abstraction. You don't have to worry about the mechanics of how things work under the hood. You just focus on what you want to have done. So armed with that as background, now let's go ahead and take a look at the Lock API interface. So this is an interface using this Spring 6 HTTP client interface feature or interface client feature. And you can see here that we have a bunch of methods we define: create, acquire, release, and so on. Look very, very, very similar to what we have on the server side. And they shield you from the details of all this stuff. Then we also have to note that these are all synchronous two-way calls, and they all return conventional Java types like Boolean, or those are built-in types or standard types, or user-defined types like lock and LockManager, but they're just returning Java types, nothing special or different about this. We use the post-exchange annotation because these are things that are going to be going to post endpoints. That's the one annotation that's slightly different from what you would see on the controller side, where it would be post mapping, not post exchange. We have the same paths. This, again, is why we want to use constants, not string literals. So if we make changes, it all goes in one place. We don't repeat ourselves and have to make changes that can be inconsistent. And these annotations here, request param and request body, are exactly the same that are used by the Spring controller. So let's take a look quickly at how you create an instance of the Lock API interface. So here's the bean that we make. You can see this is in the client beans class, which is on the client side. We have a bean, which is called get lock API, that returns a lock API. So anywhere we need a lock API, this is what's going to match to it and do the dependency injection automatically. That's the annotation. And this is the web client builder we're going to use to make a web client that will work, in this case, for synchronous operations, but we could use it for asynchronous calls too. We just don't do it in this case. And then down here, we use this HTTP service proxy factory builder to take this web client and adapt it into something that will work with this class. And then we're going to go ahead and say, please make an instance of the Lock API that knows how to use this dynamically implemented proxy. And there's actually some other stuff here that we aren't showing, but we'll talk about this when we look at the actual code here in a minute. This is the basic idea. OK, so that's an overview of the client structure and functionality. We're now going to take a look at the client-side implementation of what I just showed you, much of which is identical, so I'm not going to spend a whole lot of time on it. So here's the Lock API interface. You can see this is just good old Java code. In fact, you can use ChatGPT to generate the bulk of this. And when you get around to doing this for one of the upcoming assignments, I think I actually have you do that if you so choose. All you need to do is take the controller file for the LockManager controller and give it to ChatGPT and say, please generate me an HTTP interface file using the correct annotations. Or you can just do it yourself manually very quickly. Either way works fine. But this will basically show how to do the client side. Really don't want to spend much time on that because we already talked about it. I do want to talk briefly about the client beans part, however, because there's a little tiny bit different thing here I want to go over. So again, this is a bean. So we can auto-wire this into our LockManager test driver, which we'll talk about next. And we make a web client that connects to this particular server base URL. That's where the server's listening. In the next part of the course, we're going to talk about ways to not have to hard code these things, but for now we're doing that. And then down here, we make an instance of HTTP service proxy factory, which is associated with that web client we just built. And then we add one more thing here that I wanted to go over because this is important. we're going to set a timeout here so that after a certain amount of time, the client will time out. And this is important because I believe the default timeout is pretty short. It's like 5 seconds or so. And so what you'll find is if you have a bunch of clients banging away on a single LockManager application microservice, and they're doing a bunch of acquires where they're trying to get multiple permits, because of the way this works, even if, by the way, even if I didn't use the spinning approach, it would still be the same thing. The clients will start to time out because it'll take too long past 5 seconds. So what we're going to do is we're going to make the timeout duration be 60 seconds. And of course, we could change that to something higher if we wanted to. So that's where we're going to set the timeout duration. Now, to be honest with you, I probably should have made this a configurable parameter. So it could be set through an option or an environment variable or something. But I mostly wanted to show you how you can set the blocking timeout so that it'll only, so in this case, it'll go longer than the default. The default, I think, is 5 seconds. We want it to go for a minute. You could change it to a much larger number, but at some point, of course, you might end up with clients that hang for too long. So this is a way of being able to control that. Let's see. Oh, the other thing I wanted to talk about here on the, well, yeah, all right. So that's basically what we're going to talk about now just for the implementation part of the client.